All right, we're here at the shop at Badass Racing Engines. This is where we build some of the baddest motors on the planet. This whole show right here is on forced induction, also known as superchargers, blowers, huffers. Basically, it's an air compressor that forces both the fuel and air into the motor and makes a lot of power. We're going to talk about all kinds of aspects of different types of blowers, little ones, big ones, centrifugal blowers. I mean, you name it, we're going to talk about it. We'll start right here. This is just a little street blower. This is a wind supercharger, and let's start off with kind of a funny thing here. A lot of people call them Weans or Wheelins, and it's not, it's Wyand. Even on their catalog, it says right on the front, say Y-and. It's Wyand. You don't want to walk around sounding like a dork going, hey, I got a Wheeland blower, or a Wheeland manifold, or a Weand. It's Wyand. Anyway, this is a little guy right here, street use. All this little guy does is made for small cubic inch motors. All it does is compress air and force air into the motor. And of course, you can be carbureted. This is just a typical little street carburetor right here. It's an Edelbrock AFB. Great little carburetor. Fine for a little motor like this. You know, on one of these little guys on a typical 350 like this, you can expect an easy 375, 385 horsepower up over 400, just like that. I mean, real easy. Let's kind of go over the different aspects of the blower right here on this little guy. All blowers are belt driven. The ones we're going to be talking about are all belt driven. They come off the crank down here with a crank drive pulley. One thing though, let me tell you, not all blower motors use harmonic balancers. Some of them use a hub, and believe it or not, they use the belt as the harmonic damper or the harmonic balancer to take away vibrations from the crank. A lot of the street ones though, they go ahead and use a harmonic balancer, but some of the race ones and some street ones, you'll find that they don't use a harmonic balancer. They use that belt. But this is the drive belt. This goes in, and what's happening in here, there's a set of rotors, what they call impellers or rotors inside here. And what they do is they force air into the motor. They just grab it and force it in. And a lot of people look at a supercharger like this and they'll say, yeah, you know, the rotors, they grab it and push it in. Actually they do, but they do it opposite. The rotors in here are turning this way. They don't grab it and pull it in this way. They're actually scraping it against the sides of the edges of the supercharger. I'll show you that a little bit later. I have a supercharger that's off. I'll show you the insides. You can actually see where the rotors are and what they look like. But basically, this is what grabs the air through the carburetor, compresses it, and just forces it inside the motor. Of course, anytime you force more air in there, you got to meet it with the same amount of fuel. You always have to maintain a specific air-fuel mixture or air-fuel ratio. And on blower motors like this, the worst thing you can ever do is lean one out. You don't want to lean a blower motor out. You'd rather be on the rich side than the lean side. But just for reasons here and stuff, let me tell you, you always want about a 12.5, somewhere's in there to 1, maybe as lean as a 13 to 1 air-fuel ratio. Most normal driving vehicles, they run a 13.5, somewhere's right in there to 1 air-fuel ratio. You want about a 12.5 to 1 air-fuel ratio on a supercharger motor. Better to be on the rich side than the lean side. So we got your basic carburetor. We got the little blower right here. Of course, these mount to a different type of manifold. These are a blower manifold, and there's different types of manifolds for different types of blowers. But these little guys are really good for the street. They're dynamite little guys. Let's go over here to the big boy here. This, of course, is the mighty 671. What that means, a lot of people don't understand what a 671 is. These came on diesel engines way back when, and they were mounted on the side of a 6-cylinder diesel. And on those diesels, they were called 6 cylinders, 71 cubic inches per cylinder. So they called it a 671. That's why it's always a 6-71. Well, these were the superchargers, this size superchargers, the one that came on those. And those weren't belt driven, they were actually direct drive gear driven off the front of the motor. It was actually Bruce Crowder from Crowder Cams that was the first guy to ever take one of these blowers and figure out, hey, if I took one of those off and put it on a gas motor, that might be kind of cool. So he's the first guy that ever put one together and stuffed it on a motor, on a gas motor, and used it for a race car way back when. So that's kind of one of Crowder's claim to fame. So we come over here, it's very similar to the little guy here. We have a drive down here. This one uses a cog belt, and it's got little teeth on it. They call them a cog belt or a Gilmer belt or a Gilmer drive. We have an idler pulley right here, just keeps tension on the belt. We got the drive pulley, and again, there's a set of rotors inside here. It's mounted on a blower manifold, a specific manifold for the specific supercharger. These are the drive plates here, and just like most superchargers, these are filled with gear oil, so they do have gear oil inside here. Being that this is such a big supercharger, it's got a pair of carburetors up here. Just some basic little Holley. These are Holley 1850s. These are 600 vacuum secondaries. We cover a lot of those on different types of carburetors, including the Edelbrock carburetor here, and these in our performance carburetors video. If you want to learn on those, you can pick that up. But this is just a mild street motor, so a pair of little Holley 4-barrels on here are really good. Of course, the cool air scoop, you got to have the scoop on top to look good. Let's talk about what type of blower this is. This is called a Roots blower, and it really got its name Roots because of the guy that designed it. His last name was Roots. And it's actually, I'll tell you a little interesting story about that. In Virginia City, I was on a little mining tour in Virginia City at some of the old silver and gold mines, and we're standing there in line waiting to go on this little tour, and I look over and I tell my wife, I'm like, hey, look at that. That's like the world's largest blower sitting over there on the corner, you know, sitting on the ground there. It's kind of an old rusty thing. And I walked over and looked at it, and it looked just like this 671 right here, only big. It was a monster. So we go on the tour, we walk inside, and a lady in there is telling us about stuff, and they said, yeah, well, there's a man by the name of Roots that invented a blower to push air in here to bring fresh air into the miners. And that's where the Roots blowers kind of came into effect, and how they became invented was this old guy Roots designed it to push air inside all the mines so the guys can breathe. Kind of a little interesting story right there. All right, I've already talked a little bit about how blowers work. They force fuel and air into the motor. But let's talk a little bit about displacement. And what a blower does when it's forcing air inside of a motor, it's increasing the displacement of an engine. And engines like this 350 right here, it makes 350 cubic inches of space inside the motor simply because at atmospheric pressure, at any given time, normal atmospheric pressure is 14.7 psi. So right now, there's 14.7 psi of air pushing on our bodies, on everything in here. So when you have something where all the air is taken out of and you open it up, at 14.7 pounds of pressure, air forces itself back in. So just like on a regular carbureted motor, you know, you open up the throttle on a regular carbureted motor, and at 14.7 psi, air will go inside. Okay, well, a blower forces air in there, so it increases the displacement of a motor. And I'm sure you've all heard the term, there's no replacement for displacement. Well, that's how a blower makes its power on a motor. So consider this. If we have a 350 cubic inch motor right here, normally aspirated, and we put a blower on it, and we put 14.7 pounds of boost, okay, of pressure forcing into that motor. Well, that's double the atmospheric pressure. That also means it doubles the cubic inch of the motor. That 350 cubic inch motor is now 700 cubic inches. So figure it like this. A no-brainer way to figure out horsepower on a basic performance motor is 1 horsepower per cubic inch. Of course, we get a lot more than that, but that's just a rule of thumb. If you want just a nice running engine, a 350 horse 350, that's a nice running engine. That's 1 horsepower per cubic inch. At 700 cubic inches, that's an easy 700 horsepower. So that's how fast and simple and easy a blower can, you know, add power to a motor like that. So how much horsepower can a blower add? All right, let's think about that. The whole object of the game behind superchargers is boost in pounds per square inch, okay? So it backs up pressure inside the motor. So when the throttle's open and the intake valve opens, it forces fuel and air into the cylinder. I mean, the whole key to horsepower is a no-brainer. It's cylinder pressure. The harder that piston gets pushed down, the harder it turns that crank around, that makes power. If it's something's pushing, if you got a piston coming up and it's just a mild little explosion, it's only pushing the crank around just a little bit. I mean, there's not much pressure pushing on that crank. If we pack the cylinder with fuel and air, when the spark plug lights that baby, bang, it's a big bang, and it really pushes that crank around. It'll pull a lot of weight and a lot of power, and make a lot of power that way. So the object is, the more boost you put on a motor, the more fuel that you meet with that air, the more power the motor is going to make. Up to a certain point before you exceed what the engine can handle, and you blow the crank out the bottom of the motor, or break a piston or blow a head off or something. But everything's got variables and tolerances that has to stay in. But the object here is boost, okay, in pounds per square inch. But let's think of it like this. How much power does a blower make per pound of boost? Usually around 15 horsepower, sometimes up to 18 horsepower is about average. Sometimes you can use a rule of thumb, a general rule of thumb of 15 to 20. So figure you got 5 pounds of boost. That could be anywhere from about a 75 to 100 horsepower increase on 5 pounds of boost, just depending on the motor. Obviously, if the motor's set up better, they work perfect on stock motors. If you keep 4 or 5 pounds of boost, and 5 psi is pretty much standard when you buy a blower in a kit, they usually come making about 5 pounds of pressure. And that's about, you can figure probably 70, 80 horsepower increase on the motor, and at least that much torque. I mean, they really increase the torque of a motor. But you can use that as a rule of thumb per pound of boost of 15 to 20 horsepower in there. On stock motors, they do work okay. There's nothing wrong with it because we'll get into this a little bit later. The cam profiles work real good. Small heads tend to flow better. Pressure makes flow, okay? And the whole idea is to fill the motor, to flow enough to fill it with fuel and air and make more power. So they work on a stock motor. Well, obviously, if you set the motor up with better flowing heads and a camshaft that's designed a little bit better for a supercharger and to utilize the boost better, obviously that 15 to 20 horsepower, you're going to be at the 20 horsepower side of it rather than a 15 horsepower side of it. So that kind of gives you an idea of how much power per boost one of these things can make. It just kind of depends on the motor. How do these make boost? All right, well, we said they're forcing fuel and air into the motor. That's determined by the impeller speed or the rotor speed inside of these. And what that is, there's a shaft that goes through here and it's turning one rotor. And these drive plates here, there are gears inside here that keep the rotors in time, because boy, these babies have to be in time, because any little clearance difference one way or the other, when they do that, you know, if they're off one way, they can bind inside there because the rotors come together and they force air. All right, that's all dictated by crankshaft speed. And you've probably heard of blower drive or underdrive, overdrive, or a 1-to-1 ratio. And what the heck, you know, what does that mean? What that means is, let me start off real simple here. A blower at 1-to-1 means for every revolution of the crankshaft, the rotors in here make one revolution. Okay, and let's say this. Let's say the blower has 350 cubic inches of capacity per revolution. Then for each revolution of the crankshaft, it's forcing 350 cubic inches of air into the motor. They don't really rate blowers like that, but how we do rate them is by the size. Okay, like a 671 or a 471, those came on 4 cylinders. There's 871 blowers, those came on the diesel, the V8 engines on the diesels because they were 8 cylinders with 71 cubic inches. So it depends on the drive of the blower. All right, so if a blower is underdriven, let's say we got an 871 on this thing, okay, well that's a lot of fuel and air that's trying to push in there. Well, you don't want to drive around the street with 20 pounds of boost or something. The car's going to have a lot of blower surge. That's when you see a car, like at a car show, they come driving in, it goes rump, 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 and they're surging and stuff. It's because they're running a lot of boost, and when you're trying to idle, you get blower surge. You hear that in boats a lot of times too. When the engine's under a load, they got the V drive locked in, and they're cruising through the no wake zone or something. You hear the boat rump, rump, and it'll start leaping. That's called blower surge, and it's pretty common when you start running up in the boost. 5 or 6 pounds boost, you don't get that. But let's talk about the drive. Obviously, if we had an 871 sitting on here, that's a lot of air per revolution. This motor wouldn't be able to handle that, so we'd have to underdrive the blower, like maybe 15 or 20%. And what that means, we lay the blower back. So every turn of the crankshaft, the blower's not quite making, it's only making 3/4 of a turn or so. At 25% underdriven, it'd be 3/4 of a turn to 1 turn of the crank. That dictates the impeller speed. And anytime you compress air, it creates heat. Heat on an engine is an enemy at all times. It doesn't matter what it is. It could be naturally aspirated, fuel injected, it doesn't matter. Heat is always an enemy because what we're trying to achieve here is a dense fuel and air charge. I mean, again, we're trying to, horsepower is a no-brainer. Fill the cylinder with fuel and air, it makes a bigger bang, okay? That makes more horsepower. When a blower is compressing air, it creates heat. And what happens is, even if you feel your air compressor inside your garage, when it compresses the air and fills that thing out with 100 pounds of pressure, you touch that tank, it's hot. Well, that's expanded air. Inside the motor, what we're trying to do is keep cool air inside there. A cold air charge is a denser charge. That means when you mix the fuel with it and you light that inside the cylinder, it expands better. Hot air is already expanded. So the object is to run cold air inside here. Well, the problem with blowers is when they compress the air, they create heat. The more boost you make, the more heat it makes. And that's not what we're trying to do. We'll get into it later where some blowers have intercoolers on them. What that does, it cools the incoming air charge down, or aftercoolers, and that cools the charge down after it's been compressed and goes into the motor. It'll cool the air down. But the object is to keep the air cold. Well, smaller blowers, you got to run the impeller speed up real fast to meet the boost. Like, let me give you an idea. This little guy right here, the capacity is like 177 cubic inches of air per revolution. This is a little wind 177. You come over here to the 671, and obviously it's about twice the size of this little guy right here. So For this guy to make the same amount of air movement or compress the same amount of air as this one, this guy's got to turn 3 or 4 times, where this one's only got to turn once. So the impeller speed inside here is turning a lot slower, making a lot less heat. So that's kind of the way those work. You can slow the impeller speed down or speed it up, that as opposed to boost. And different size blowers meet different demands for the motors. I mean, if this 350 right here and we put an 871 or a 1271 blower on here, we'd have to underdrive the crap out of it. Otherwise, it's going to blow the heads off the thing because it's got so much air per revolution. We got to lay that blower back and underdrive it. And the way we do that and the way we control that is by the pulleys, the pulley sizes on here. And if we come over here and look on here, all right, so we come around here, we can see the different pulley sizes on this one right here. This particular pulley, if we look real close right here, of course it's upside down, but that's okay, you get the idea. It's 38. There's a number 38 on there. That tells us there's 38 teeth around here on this drive pulley, on the upper drive pulley. And what that means is we need to know the size of the pulleys for the amount of drive that we have. I mean, put it this way, if this was 38 teeth, and then down here on the crank pulley, this is the drive pulley off the crank, and that was 38, that would be a 1-to-1 ratio. That means this blower would be a 1-to-1 ratio. Being that the crank pulley is slightly smaller, and this one's slightly bigger, this larger pulley up here is turning slower at a slower rate of speed. So it's turning less speed than the crank, so it's underdriven. This particular blower, because of the amount of capacity it has and the volume inside of it, to get 5 or 6 pounds of pressure on a mild motor like this, we need to underdrive it. And they'll say like 10% or 15% underdrive or 8%, and that's all dictated mathematically by what size pulley it is, by how many teeth it is compared to the crank one. The beauty of a blower is if 5 or 6 pounds of pressure inside this doesn't make the kind of power that we want, I can go down to a 36 tooth pulley, and that's 2 teeth smaller. That'll step it up to maybe, like right now, this is probably 15% underdrive. I could step it down to maybe a 10% underdrive. That'll bring the boost up to 7 or 8 psi, and that'll give us another 40 to 50 horsepower just like that. You always want to check jetting after that, though, because we've increased the air being forced inside the motor. You still got to meet that with fuel. But it's simple. It's very convenient to have a power adder like that that's there 24/7. Nitrous oxide is really cool. We have a video on that too. And problem with that, though, is if your bottle's empty, you don't have the power. And you can't be driving around with nitrous oxide with the bottles open all the time. A blower is there 24/7. Anytime you mash the gas, these things go into boost. And man, when you're on a boost, it's raw power. I mean, the torque is just instantaneous. And that's a good thing most of the time. Sometimes it's not. There are other blowers that don't do that. We'll get into those a little bit later when we talk about centrifugal blowers. All right, what we have here is a 500 plus cubic inch big block Chevy. This has an 871 on it. We talked about that, you know, the 671s were on 6-cylinder diesels with 71 cubic inches per cylinder. This was off a V8 diesel with 8 cylinders at 71 cubic inches apiece. Basically what it means, it has more volume. It puts out a lot more air. And the reason you need more volume of a blower, it's got a larger displacement. If we put a 671 on this motor right here, the rotor speed, the impeller speed, it'd have to be spinning a lot faster to get the same amount of boost. So we use a larger capacity blower that has a lot more volumetric output of air on a larger cubic inch motor like this. So that's an 871. Basically, they're the same height as a 671. It's just that they're a little longer. This one's 3 or 4 inches longer, so it's longer this way. The rotors are just longer, it's just more capacity. So let's look at some of the things on this. This one's fuel injected. It's got, this is a BDS blower. It's got their electronic fuel injection on it, which is kind of cool. It gives you that race look and everything, except easy starting, easy running, high tunability, instant throttle response. It's real nice. We'll come in and look at some features here on this. This one uses an 8mm drive rather than a 1/2 inch pitch, so it's got the little round teeth on the belt right here. And when we look down here, and I said earlier, some engines, some supercharged engines, they don't use harmonic balancers. So we come on down here and look at this. What are we missing right here? No harmonic balancer. It uses the belt as a damper for the crankshaft vibrations, the harmonic and transient vibrations. There's no balancer down here. We actually use the belt. So some systems just don't use harmonic balancers. That's no big deal. We have the belt tensioner right here. And right up on top here, there is this funny little doodad up here. There's a little button right here on the front. What that is a pressure release here that when sometimes air pressure builds up inside the gear plates and you don't want that. So you can actually push that and it blows the pressure out of the gear plates. I usually find that there's really no pressure in there, but it's just a little extra feature there if you want it. Looking at other things, typical blower intake manifold. They all work about the same impellers, same everything. Of course, these run on up in size to up to 1471 these days. Of course, there was no 14-cylinder diesel motors, but that's the equivalent of a 14-cylinder engine is the capacity of those blowers. They still use that as a unit of measurement. Think of it like this. A top fueler in a drag race, they burn 16 or so gallons, 16, 18 gallons of fuel in a quarter mile. That's a lot of fuel going through there. So you gotta, they have to pump a lot of air in there to meet all that fuel. So that's how they're making their 7,000 and 8,000 horsepower these days. All right, let's look at the backside of this 871 here. All right, and again, like on all Roots blowers, we have the rear gear plate, and these are all pre-greased inside. The fronts, of course, have the gear oil inside of them. The back right here is all greased. What's inside here are the bearings and the gears where to keep the rotors timed so they don't go out of sync or anything, because boy, it'd be a catastrophe inside if they got off sync. It'd be like grinding gears. We come on down here, and there's a safety feature here. This also has a pop-off valve on the back side, and again, if the engine happens to hiccup, whether it is an ignition problem or a lean condition problem or anything like that where it actually spits, it'll blow the plate back off and let the pressure back out, and then the springs will slam it back shut, so it's good to go. You don't have to change anything on that. Come on over here, and there's a couple ports right here. What these are for, basically, you can use them for vacuum, but really what's important on a supercharger, even on 671s and pretty much on any supercharger, whether it's a Roots type or a centrifugal type, you need a boost gauge. And this is where the boost gauge comes in. It'll read manifold vacuum and pressure that comes inside there, because when the engine's just running and just idling, you're not under boost. So you will have vacuum at an idle, but when you give it the throttle, it will go into boost mode. And you really want to know how much boost you have, because that's going to determine how much power the motor's going to make and how much load you're putting on it. Let me tell you a quick little story. It's kind of a funny one. A customer of mine, it's actually a friend of mine, had an engine that he had built and had a supercharger put on it by another place. They didn't put a boost gauge on it. And he brought it over and he says, "Hey, Aaron, check this thing out." He lives quite a ways away from here. That's why he didn't have me do it. So he brings it up, says, "Hey, check it out. Take it for a spin." I took it for a spin. The car screamed. It was fast. I mean, it was an easy 11-second car, and in street trim. So I took it for a spin, come back, and went, "Yeah, that's really cool, but how much boost is it making? I mean, this thing's really going." Mind you, it's a stock engine, okay? It was just a factory Chevrolet, and it was a 350. And he goes, "I don't know." I said, "Yeah, you don't have a boost gauge. What'd they set it up as?" He goes, "I don't know. They just said it would make it go." And about 2 weeks later, I get a call from him. He goes, "Hey, I think you're right on the boost. I needed to know because the engine grenaded. It blew the crank out the bottom." And come to find out, he called the company that had sold him the products and stuff. They'd set it for like 18 pounds of boost, 16 or 18 pounds of boost. Well, a stock 350 can't take that, and that's what it did. It just completely blew the bottom end of the motor apart. So you really need to know what kind of boost you're running, and that's a vital sign. It'd be like, it's just as important as having an oil pressure gauge or a water temperature gauge. You really need to know what's going on in these things. All right, let me put an old wives' tale to rest here, once and for all. A lot of people out there say, "Oh, blowers aren't reliable on the street," or they make the motor real quirky and stuff like that, or they don't last very long. That's BS, all right? Think of it like this. Up until modern times recently, when turbos really became popular, everything from, probably the 70s on back, and all the diesel trucks, carrying food back and forth and products back and forth all over the nation, all over the world, all the Caterpillars out there and all the big land movers and earth movers and stuff like that, they all run, these big Detroit diesels and Cummins and stuff like that. And guess what they got sitting on the side of these diesel motors? Superchargers, okay? And those things run day in and day out. They're really reliable. They're designed to go for a long period of time. Just because they're on a street motor or sometimes on race motors, of course it's not going to last on a race motor because the whole motor's not going to last. It's a race motor, all right? They break. Sometimes they break before they get off the starting line because they're so on edge, they're an accident waiting to happen. But on a mild street motor, I got blower motors that I built 10 years ago. They're still driving around out there, okay? So that's a wives' tale. And what the funny thing is, you usually hear stuff like that from guys that have never even owned a blower. Like, "Oh, I heard they're not very reliable," or this or that. And it's like, watch where you take your advice from, okay? Those guys need to not quit their day jobs. But yes, they are super reliable. There was a thing back in the, in the 60s and stuff when I was a kid, where blowers weren't legal on the street. Not only were they not street legal, they weren't legal to run. And reason what that was for, gas engines and diesels are completely different in the whole physics of how they work and everything. On a gas engine, we can what we call cough or spit, and when an engine spits, you probably get that in the morning. When an engine leans out, you drive along, you go to give it the gas when it's cold, you go tuh, and go, and it pops. You do that through a blower, and I'm sure you've seen it at the racetrack where the blowers explode and come off the motor. I mean, they'll blow in pieces. In fact, to a point these days where we'll have straps on the blower holding it down and blankets over them so they don't explode. That's from the engine coughing. When you got the blower inside shoving air down inside, and you got all that pressure built up in there, when an intake valve hangs open and you get spark in there and it lights the fuel and air mixture under pressure inside the manifold, that manifold's coming off. I mean, boom, it's gone. Okay? Well, years ago, blowers weren't legal on the street because they didn't have what they call a pop-off valve. And what that does is when the engine spits, it blows this valve open and lets the pressure out before the blower explodes. And let me show you over here. This 671 here is a street 671, and all street blowers have these on them. This down right here, this is a pop-off valve. Basically, these springs are pushing this aluminum plate tight against the intake manifold, the back of the intake manifold. Well, there's a hole inside there. When pressure builds up beyond a given amount of boost in here, this valve opens. It'll open and let all the pressure out before the blower comes off. And that's just kind of a safety feature that they had. Way back when, they didn't have these things. So you're driving around on the street and your engine leans out a little bit, or you get a misfire in the ignition and you get a spark when the intake valve opens, and boom, blower would come off. So they really weren't street legal. Now they are. So a lot of the old wives' tales about, oh, they're not legal on the street, or they're not reliable, they don't last, that's all not true these days. These are true. Race blowers do come off because they don't run these things. They're running so much boost, these don't really work. Let me show you one other safety feature that most blowers have on them. You know, the blower itself is mounted on the manifold with studs. That would be the studs right along here. There's usually four on each side, so there's 8 total. So 1, 2, 3, 4. These studs are most of the time made out of aluminum. In fact, I don't think I've ever seen them made out of steel. They're made out of aluminum, and they're only good, the nuts right here are only good for 10 pounds of torque. That's about all you put on is about 10 or 12 pounds of torque, and you're done. That's kind of another safety feature. If this thing builds up so much pressure inside and the pop-off valve can't take it, you want these studs to break away. In fact, there's a couple companies that make breakaway studs for race motors that break at a certain pressure level. So rather than holding it down and the whole thing exploding, these studs will let go and the blower will lift up and then come back down and kind of sit there, unless the belt tears it off or whatever, but that's what the straps are for. But you'll actually see them, boom, they'll blow like that. And that's because of the studs right here. But that's why you see them, they have aluminum studs, and you certainly can't go cinching on these things. Like I say, it's only about 10 or 12 foot-pounds of torque, and that's that. I talked to you a little bit before about Gilmer drive or cog belts and stuff like that. There's a couple of terms, though, I want you to understand. We'll go to this one right here. This is a cog belt. This is your typical street blower design. It's an older drive design, though. If you notice, the teeth on here are square. This is what they call a 1/2-inch pitch. And you can see right here, you know, they're cut a little bit square, and the teeth on the belt are actually square. We come back over here. This is a little more modern blower right here. This is a little modern design. This is a blower drive service. They're a fantastic blower. So what they call them BDS for short, blower drive service. It's an 871. It's got a little more modern design on it, what they call an 8mm. Okay, and what that is, if you look right here, these teeth are rounded inside. And if we look at the belt, the teeth on the belt are round also. And that's just a little newer design, a little bit better grip. It's just something that with technology today that they were able to figure out that you don't get as much wear and tear on the belt or slippage. And while I'm here at the pulley, we talked about the amount of teeth on there before. If we look right down on here on the bottom, it'll show the amount of teeth. They're always stamped on there. It looks like 56 on there. And that tells us that there's 56 teeth on here. That's that size of pulley. If we want to go up in boost, what would we do? Smaller pulley. If we want to drop the boost, we go to a larger pulley. That just controls the impeller speed on here of the rotors. We can adjust boost accordingly. All right, let's talk about another little subject right here. We talked about, you know, blowers being reliable on the street and stuff like that. But what about the motors, a blower motor? I get this question asked a lot when someone wants to purchase a blown motor from us. And they'll say, you know, okay, how reliable are they? And, you know, how hard is it on the motor, you know, to have something like that? Well, it's simple. Anytime you increase horsepower and torque, you're increasing strain on the motor. Okay, think of it like a socket. You know, if you have a socket and a breaker bar, and that socket's good for up to 200 foot-pounds of torque, okay, and you know that at 205 foot-pounds, that socket's going to break. All right, well, if you're pulling on that socket at 50 pounds, you can pull that socket all day at 50 pounds and you're not going to hurt it. But if you're pulling it like 198, 199 pounds, that socket's on the edge, and pretty soon the fatigue is going to set in and it's going to let go at 199 pounds, okay? It's not going to make it to 200. So, you know, same thing with a motor. On a blown motor with like something like this here with 5 pounds of boost, this thing makes, at 5 or 6 pounds of boost, this motor right here with these aluminum heads will make an easy 450 to 500 horsepower. Real simple. 6 or 7 pounds of boost, it'll make 500 really easy, okay? Well, trying to get 500 horsepower out of a naturally aspirated motor is a pretty good feat, especially on pump gas. We're talking pump gas, okay? Most of you out there aren't building race motors. If you already knew how to build race motors and stuff, you probably wouldn't be buying these videos, all right? So I'm sure you're building street motors, and that's what I'm trying to explain to you, that on pump gas is what we're talking about here. And 500 horsepower on pump gas with a blown motor, it's actually easy on the motor. The motor is actually very tame. It's not running on edge. Everything, you know, when I show you how to build one, everything's just fine. You're not straining anything. Getting 500 horsepower out of a naturally aspirated motor, especially on pump gas, is hard to do. I mean, that takes a big boy stroker. It takes some radical camshafts, some good compression, and that motor's on edge. So if you take a 500 horsepower blown motor and a 500 horsepower naturally aspirated motor, the naturally aspirated motor is not going to last very long because it is on edge. The 500 horsepower blown motor, that's nothing. Boy, that's just cruising along, and you're not really hurting much of anything. So what I'm getting at is blowers are less strain, less, how can I say this, less wear and tear on the motor than one that's naturally aspirated with the same amount of power. And think of it like this, a 500 horsepower naturally aspirated motor, they got a great big camshaft, so that means your idle vacuum is very low. They're bumping and grinding at stop signs. They're idling different all the time. They don't like hot weather. I mean, there's a lot of things that go on with a really bump and grinding high-performance motor. Supercharged motors, they got great vacuum because the cam profiles are small. They got awesome throttle response. They make torque out the wazoo right off of an idle, where the 500 horsepower, basically a race motor is what it is, running on the street, they're quirky. They're real quirky. It might make 500 horsepower, but because of the cam profiles, you can't use any power accessories or anything like that. And there's all kinds of little problems. But the blown motor, shoot, they're there all day. You can run them all day. So it's less strain on the motor with the supercharged ones than it is on naturally aspirated. All right, we've talked about blowers and how they work. Now let's see the insides of one. This is a BDS 871 I just showed you a second ago. These are the rotors that are inside here. And I've already talked about the rotation of a motor. You know, most people think the rotors come in, they scoop air up, and they force it down in. They don't. They actually force it against the sides. And if we see here, this is the direction of the motor right here. This is the rotation of the motor right here. So as they come around, these rotors actually flip together. They grab the air. Each one grabs air up here, and it scoops it along the sides. That's why these cases are shaped like this right here. It forces air alongside the cases and down inside the motor. And you can see these rotors turning here just like that. Okay? You can imagine what that's like at RPM, at 7,000 or 8,000 RPM. These babies are really humming around inside there. But that's what they do. They grab a lot of air. Well, what's inside, as you can see, are the rotors right here and some machine surfaces. And boy, these are some really tight tolerances on these. They're coming really close against the sides of the casing right here. They call the outer part the casing. Okay, so the rotors, when they scrape up against the side, they're really coming close, and they have a machine surface right here. Okay, this particular supercharger, the rotors are aluminum. Okay, most of them are aluminum, but some of them have Teflon strips, and you might have heard that. Oh, my blower's got Teflon strips. Those strips run along these edges right here, right on these machine surfaces. And what they do, they'll actually Teflon strip it. What they do is they actually make contact with the outer casing of the supercharger. These don't. These come really close, just a couple of thousandths of an inch, if that, for the blower casing. So, but the Teflon strips, though, they actually scrape and wipe. They act just like when you squeegee your window off and you're taking water off the window. They do the same thing. The rubber runs along. Well, they use Teflon. The problem with Teflon strips are they wear out or little pieces come off. So a lot of race guys will use those because they want a tight fit. They want all the boost they can possibly get. Where a street guy, you want longevity. You don't want to be taking it apart and finding that there's a whole piece of Teflon missing off of a rotor vein here. So most street motors do not have Teflon strips in them. They just have the impellers. But you can see here the rotation, like I was talking about, a little better there, of how it goes. And they come up, they grab air here, scoop it around, and force it down inside the motor. All right, off goes the 871. If you look inside, there's the blower manifold right there. And in the middle is where the fuel and air gets compressed by the supercharger, and down inside is where it goes right into the heads. In fact, if you look close there, you can see the intake runners that go directly from the manifold into the cylinder heads, where it goes through the valves and into the cylinders and feeds the motor. As we look inside the intake manifold here, you can see where the intake manifold has been port matched to the heads, and the heads have been ported also. That creates a smooth transition of fuel and air going from the intake manifold into the heads, and has less reversion and better flow. Makes more power. So now we're going to go on to another type of blower that's real popular. It's called a centrifugal supercharger. All right, this is one right over here. This is an ATI Pro Charger. It's what they call a D2 model, which is one of their largest models that they make. Of course, this is a 500 plus cubic inch motor, so it needs to be a big blower to be able to fill 500 plus cubic inches worth of air with blower. Obviously, if we had a little teeny blower on there, we'd have to spin the impeller speed up so fast it would never make enough boost to do anything to this motor. So we got the Roots design motors here. We're going to look at the centrifugal here. These basically work very similar to a turbo. Basically, it is a turbo. It's just belt driven. And what you do get with this is more instant boost than a turbo. Turbos, you've probably heard the term turbo lag, stuff like that. And turbos are driven off of exhaust, where being that this is belt driven, it's always in time with the crank, where on a turbo you give it the throttle and you have to wait for the engine speed to come up, for the exhaust velocities coming out of the motor to spin a turbine, which also spins the inlet turbine on this, and it sucks in air from the backside here, forces it around. It's basically a fan impeller inside here, brings it on up, and we have a carburetor right here. What it does is it forces air and right on through the carburetor, and the carburetor meters the fuel and puts it inside the motor. This is what they call a blow-through design. And there's a couple different types of these. We'll see one a little bit later also, very similar to this. But blow-through designs, these actually go back quite a ways. The old Studebagers came with these on them. Some of the early 66 Shelbys, some of those had a Paxton supercharger. Paxton was a pretty well-known one way back when. Of course, we got really good ones now by Vortec and ATI and many other brands now. They're all very similar design though. They're all basically a turbo impeller that draws air in, compresses it inside the housing right here, forces it out of this discharge nozzle right here, discharge tube, right on into this air bonnet here, and blows it right through the carburetor. These are very tame on the street. And let me explain. We talked about boost before and stuff, but when does boost come in? And what this does is, when you're driving around town, these are on very low boost. You're only like you're idling at anywhere from 0 to 1 psi a boost. They really don't make, in fact, even Roots blowers, you're really not idling at any boost. When you give it throttle on these though, they don't come into boost until the RPM comes up. So if you watch your boost gauge and your tachometer, as it comes up, they both kind of follow up together. So if this makes, say, 15 pounds of boost, you watch your tachometer come up, and as it gets up to 4,000 or 5,000 RPM, the boost is coming up with it until it gets to a certain boost range. Roots blowers, as soon as you crack the throttle open, they're into full boost because they're what they call a positive displacement blower. They always make the same displacement no matter what. So when you crack the throttle wide open on a Roots blower, even right off of an idle, it goes into full boost right now. That's good for some things, but not good for others. And let me kind of explain that. You're at the racetrack, you got street tires on, and you got a small little supercharger like this little guy, and it makes 5 pounds of boost, say. As soon as you come off the line and you nail the throttle, you're into full boost. Well, it's easy to spin the tires. You might not want that. A centrifugal supercharger, though, at low RPMs is not going to put out very much boost. Boost isn't going to start coming in until you're off the line and down the road and the revs start picking up. Then the boost comes in. If you've ever ridden in a turboed car, there's a lot of factory cars that have turbos on them. It's a very smooth power. As the throttle comes in, it just keeps setting you in the seat more and more and more. Roots blowers, especially on a race one, they're violent. I mean, you mash the throttle on those and it's boost right now, and it's violent. I mean, you're bam, right on boost. And that can come in good on race cars with big slicks or something like that. You want to hit it right off the line, that's great. Or if you're playing around on the street, you want to smoke some tires off or something, it's nice to have the power right there. But a centrifugal won't do that. Because of the way that it makes its boost. So there are differences. They do the same thing. They both compress air, Roots blowers and centrifugals. They do compress air. It's the same thing. They're forcing more than atmospheric pressure into the motor. but they'll do it at different times. So a roots blower will come on a lot sooner, centrifugals come on a lot later. The difference is too in these blowers, roots blowers, they run gear oil inside the drive plates, what they call the end plates or drive plates. And you can see there's a fitting up on top here. These run 90 weight gear oil inside. If we look back over at this one here on the front of the blower drive service one, all right, if we flip this idler bracket and pulley over here, you can see even the blower drive service one here has a sight plug on the front that you can visually see the oil level inside, the gear oil level. And so these do have gear oil inside of them. Centrifugals though, some of them are self-contained where they have a reservoir inside here that uses transmission fluid or oil. This particular one though, you can see a couple of lines on here. This uses engine oil pressure. It comes on up and feeds the bearings. Because you know the impeller speed on one of these things are fast. These things spin on average 35, 45,000 RPM. At real high RPMs, these impellers inside here can spin up to 55, 60,000 RPM in extreme cases. In normal cases, they're up to about 45, 50,000 RPM. I mean, that's a lot. That's way up there. So the bearings inside here, I mean, they're taking a lot of abuse and they build up a lot of heat and stuff. So engine oil comes in and it sprays oil onto these bearings just to keep them lubed up and everything. And then there's a drain back line that'll come out and come back and go right back into the pan. So it just kind of recirculates oil out of the motor. All right, we talked about blower surge before in the roots blowers. You know, one of the beauties of a centrifugal blower though is that they don't get blower surge like that. You can have a fairly radical street car like a 9-second or a 10-second street car, and that's a pretty radical car, and which requires a lot of boost to get you up into that kind of power to propel a car that fast. You don't get that kind of a surge with a centrifugal blower. So that's kind of nice. You know, another nice thing about centrifugals is they fit under the hood. They're designed to go right up underneath the hood. Of course, sometimes with a manifold like this and a bonnet on top, you might need a cowl hood or something like that. But a lot of times they'll fit under most medium-sized cars and large car hoods without a problem. And that's kind of fun for the guys that want the sleek lines of the car without having scoops or anything like that. These come in real handy. But then there's those of us that like the big top of the blower and the carbs and the scoop sticking out of the hood too. So to each his own, but you have best of both worlds depending on which blower you want. And one thing that superchargers have troubles with is belt slippage. And we come over here and we look at this little guy, this little Wyand 177 here, and you can see it's got a little serpentine belt. This is the same type of belt. It's ribbed inside. It's got long ribs that run long ways, not really teeth, but just ribs. Same kind of a belt that all modern cars use these days for their fan belts and accessories and alternators and stuff like that. Being that there's belt slippage problems, there's always an ongoing battle of bigger pulleys and bigger belts. This is a 6-rib. You'll see advertisements for kits for an 8-rib system. You'll go into other blowers like this, on this centrifugal right here, and they'll have 8-rib, but they'll have a 12-rib option or a 10-rib option. So pretty soon the pulleys get wider and wider and wider because they're trying to eliminate the belt slippage. Because you go nailing a throttle and you go in the boost real fast, and the engine starts spooling up and the impeller and the drive pulley of the blower can't keep up. Well, on something like this though, we eliminated it by putting a 2-inch drive cog system on here. That just eliminates all belt slippage put together. I mean, there is none, and it's instantaneous boost. Speaking of instantaneous boost, so let me tell you something here. There's a misconception out there about turbos, and basically this is a belt-driven turbo. I mean, there's really nothing different about this than your average turbo out there, except for the fact that it's belt-driven. Turbos, instead of a belt drive, they run the exhaust. It runs an impeller that sits inside the exhaust, like a paddle wheel does in a river when they're getting water off for a paddle wheel to run an old sawmill or something. All right, well, when you have a belt like this, it makes instantaneous boost. On turbos, you get what they call turbo lag, and that means as soon as you nail the throttle and the engine starts coming up in RPM, the exhaust gases coming out need to catch up in speed to spin that impeller. And as that's happening, it spools that impeller speed up, turns the input or inlet impeller up and compresses the air. So you get this lag time. Now, modern technology is getting better, so we don't really have too much turbo lag anymore. But I want to clear up a misconception. There is a wives' tale out there that says turbos give you free horsepower, and that's a bunch of BS. Turbos do not give you free horsepower. The biggest, baddest cars on the planet or vehicles on the planet are top fuelers, and they use blowers for a reason. You know, Indy cars are nice cars too, and they're very fast and very powerful. They use turbos on those for a reason too. It's an entirely different ball game, but they're also not 8,000 horsepower motors. Okay, so turbos have been tried on fuelers, and it really didn't work. Maybe the technology wasn't up to that point or whatever, but they didn't work. Superchargers work. but it is not free horsepower. The reason I'm saying that is because you have the turbine inside the exhaust, and that's basically constipating the exhaust. I mean, what goes in needs to get out. You eat too much and you can't get it out, guess what? You don't feel too good. Well, it's kind of the same thing. You're trying to put fuel and air in the motor and spooling it up, and it's trying to get out and turn that impeller. Your low end torque doesn't come up right away. You got to wait till that exhaust gas really gets moving to a high velocity and then starts turning that impeller. Then it starts making its boost. So it's not free horsepower, okay? I just wanted to clear that up because that is a misconception out there. All right, I thought I'd show you another type of centrifugal supercharger here. This is a Vortec. My buddy Willie down at Vortec Engineering sent this up to me. And kind of gives you an idea. We looked at the ProCharger, the D2 ProCharger earlier. This is more of a street strip version right here. This is Vortec's new V2 supercharger. Works very similar to all the other centrifugals. We can flip it around here. We have the inlet right here. This is where all the air comes in and gets sucked in by the turbine right there. It compresses inside here and comes out this discharge nozzle. Very similar to pretty much the way all centrifugal superchargers work. It's got a serpentine belt drive right here. This is a 6 rib. Of course, we can go to an 8, a 10, or a 12 rib. They even make cog belts for these things also. Very, very simple design. These things work really good. We can come over here and grab one of these. Here's another one. This is very similar to this one. The difference between this one is the discharge nozzles come straight out the back. Exactly the same supercharger, just for different applications. Sometimes you don't have the room inside for the discharge tube to come out here and come around and go to the carburetor or the fuel injection or whatever type of induction you have on your car. This one right here comes straight back, straight out. Just makes it easier. You can also clock these. This can turn, so this discharge nozzle can come this way or whichever way you want to help you get a better installation on these. I'll show you one more. This is the Monster D2 right here, just to give you a size difference between these guys. Pretty big difference in size. This one right here is good for, easy 10, 12 pounds of boost all day on a 350 cubic inch motor. You get into something like this thing will make 30 pounds of boost on 450 cubic inches. I mean, obviously it's a larger blower. Look at the inlet size here compared to the inlet size over here. I mean, it's massive. This is a huge turbine inside here. Large discharge nozzle, large inlet means a lot of air. It's a big volume. Use these on very large cubic inch motors. Something like this might not put out the right amount of boost for a large cubic inch motor. This one's capable of flowing X amount of CFM, where if it was a large motor, like say 500, 550 cubic inches, this little baby, the impeller speed would just be screaming just to make out, 5 or 6 pounds of boost. Where something like this on 500 cubic inches, every revolution of this turbine right here puts out more air and volume than this guy does. So obviously something like this on a bigger cubic inch motor is the way to go. In retrospect, something like this on a small cubic inch motor is not the way to go. You don't want to put 30 pounds of boost or even 20 pounds of boost to, say, a 302 Ford or a stock 350 Chevy or even a mild one. You blow the crank right out the bottom of the motor. All right, this might look familiar to you. This is the intake manifold, carburetor, and air bonnet that's off that 500 plus cubic incher I showed you with the D2 ProCharger. We're going to talk about air bonnets, and this is the air bonnet. And there's different styles of them. This is a typical one that comes with most kits that do a blow-through design where the carburetor is exposed. This is all right. These work okay. They come in some kits. The problem with these is the air comes in over here, and it kind of doesn't really get directed down inside the carburetor very well. It kind of, the way the shape is right here, it's moving around, swirling around. We really want to try and get a smooth flow of air going right down inside the carburetor. Well, for that, there are other types. This one's made by Carb Solutions Unlimited down in Southern California. This one right here directs air right into the carburetor. You can see it's a lot better design where it comes down, the air gets directed through the carburetor a lot better than some of the other generic designs. Inside it's a lot smoother. It just directs air. Like I say, it makes a better flow going through the carburetor, and the whole idea of horsepower is better flow. Systems like this or bonnets like this, they make the carburetor work a little bit better too, because there's a little straighter run of air going through the carburetor instead of such turbulence from the undirected air from another type of bonnet. And speaking of different types of bonnets, there's also an enclosure one, and we have one right over here in this car. And this right here is a different type of air bonnet. Actually, it's an air box, sometimes called a clamshell, because it's actually two halves put together. This right here is a 65 Mustang. We did this motor a couple years back. It's got a Paxton supercharger on it. This is their new series, the Novi 1200. They make a Novi 2000 also, which is a little bit larger, has a lot more volumetric output, makes a lot more boost. But the 1200s work really well on 302s and 351 Windsors and great for Mustangs. They make a Mustang kit like this that bolts right on. So just like all other centrifugal superchargers, this works the same. We've got a serpentine belt right here. This is actually an 8 rib. It's a little bit wider than the factory 6 ribs that they come with. The blower right here compresses the air. It comes out the discharge tube right here and goes into this air box where it gets pressurized all around the carburetor. And inside here, we have a carburetor. That right there is your typical Holley 750 double pumper. It's modified a little bit for a supercharger. Inside these air boxes like this, though, you can use pretty much a basic type of any type of carburetor. It doesn't have to really be highly modified. The blow-through systems that we talked about before that uses the air bonnets, those need to be pretty well set up if you're going to run that type of a system. Air boxes like this, though, because the whole carburetor is in its own atmospheric pressure, they really don't have to be highly modified. They work real well like this. This is a great setup. Really simple. It works really good. You can get a lot of horsepower to one of these things. There's a lot of 10-second cars and 11-second street cars running around with these little superchargers on them. I'll show you another little thing here. This car also has a bypass valve. You might have heard about on turbos, you heard the term wastegate. And what does a wastegate do? Well, this is a bypass valve, and it works similar to a wastegate on a turbo. Basically what happens is when you're on the throttle and you're at wide open throttle and you're cruising down the drag strip or getting on the freeway, the engine's revving up, the blower's revving up, it's putting air boost out, okay, and then you go, uh-oh, I gotta hit the brakes. Or you're at the end of the finish line at the drag strip and you're going from 6,000 or 6,500 RPM and you let off the throttle all of a sudden. Well, the throttle plates inside here, the butterflies slam shut. Guess what? The blower's still turning at 6,000 RPM. That impeller inside here is screaming, and it's still putting out all the boost. So what happens is it backs up all this pressure in here and backs it up into the supercharger. It can actually cause damage to the supercharger, to the seals and stuff like that. So what happens is, just like much like on a turbo, there's a bypass valve over here, and what this does is at certain pressure levels, it'll open up and let the air blow out. It'll bleed it out. So you can't back up that much pressure inside the blower here. It's just a safety device. Cars running 6 pounds of boost, 7 or 8 pounds of boost, really don't need it. A lot of kits don't come with them if they're just 5 or 6 pounds of boost. You start getting up into 9, 10, 11, 12 pounds of boost or above, it's a good idea to have a bypass valve because you really don't want to destroy the supercharger, take a chance on hurting it when you've got a good investment like that. All right, let's talk about a little problem that some of these kits have. When you purchase a supercharger kit, most of them come with just a little K&N air filter, such as this one back here. And that's fine, they're great air filters. Problem is, though, they're mounted in the back side here, right above the headers and right next to the engine. And guess what's back there? Nothing but a bunch of hot air. That's not real good for the supercharger. It's hard to compress expanded air. The ideal situation would be to compress cold, dense air, which is a denser charge going inside the motor. Well, unfortunately, you're kind of stuck with that sometimes. There are different kits that mount superchargers on other sides of the motor. You can see over here there's not much room. You got a solenoid, you got a coil, there's a battery. There's not much room over here. There are kits that mount these on the driver's side, and what's kind of neat about that, if you don't have power steering or accessories like that, you can run a fresh air inlet, and I'll show you. This is one right here. This is actually off my old car. And what it would do is reroute the air instead of coming in through a filter through the back of the supercharger here. This would mount to the back of the supercharger via a little rubber elbow, and this would run it on down to underneath the car right here. So air coming through the underside of the car, nice cold air, before it hits the motor and heats up, comes through the air filter right here, comes on up in and gets compressed by the blower. So you're actually compressing more air, making more horsepower. You might notice something on here, a little bit of nitrous oxide. We talked about intercoolers before, and what it does is it cools the temperature of the air coming out of the blower before it goes into the motor. Well, this is another way of intercooling an engine, is using a little shot of nitrous right there without the fuel, just the nitrous gas itself, because it's very cold, it's way below freezing. And what that would do is even cool the inlet charge of air going into the blower even more. We can learn about more on that if you pick up our DVD on nitrous oxides. But this is a good way to go if you have the room for it. All right, we're going to talk about intercoolers here. What is an intercooler and what is it used for? Well, this is an intercooler. And you've probably heard the expression intercooled twin turbo in sports cars and stuff like that. This is an intercooler. And basically all it does is the outlet of the supercharger, like a centrifugal supercharger such as a Vortec or a Paxton or anything like that, anytime you compress the air coming out of it is hot. It makes hot air. Well, hot air is not good for the motor. So what will happen is it'll come out of the discharge nozzle of the supercharger and be piped inside an intercooler like this. The air goes through here, comes out, and then goes into the motor. Well, what that does is this is mounted on the front of the vehicle, just like a radiator. As you're driving down the road, cold air is coming inside here, and it helps cool the compressed charge down that's going inside the motor. Heat is an enemy in superchargers, and you really don't want to put forced hot air inside the motor. It's already expanded. What you're trying to do is put forced cold, dense air inside. Well, this helps cool the charge down that's going inside the motor. There's all kinds of different shapes of intercoolers. This is an air-to-air intercooler. What that means is air's going through it and air cools it. It's on the front of the car. It can be mounted in any kind of location, usually in front of the radiator because you want this to be as cold as air coming through it as possible. Some, like on boats, on Roots style superchargers, they use a air to water or water to air system. And what that does is underneath the supercharger, there's a large plate, and it looks very much like this inside. And what they do is they take cold lake water, pump it right through the intercooler, so as the air gets forced down outside the supercharger, down through the supercharger into the motor, it passes through this radiator, and instead of air coming through it, it's got cold water. And that makes the charge that's compressed outside or coming through the supercharger cooler. Makes the motor run better. Just so you kind of understand this, if you have a non-intercooled motor, say making 10 pounds of boost, one that's intercooled that's making, say, 6 or 7 pounds of boost will actually make more horsepower, simply because the air charge that's going in is cooler and denser, and it expands more inside the motor. And the whole key of horsepower is expanding a mixture of fuel and air inside when you light it with a spark plug. Well, if you put a denser charge inside, when it lights, the expansion's even bigger, makes more horsepower. That's pretty much what an intercooler does. They're real simple. All right, now we're going to talk about induction and carburetors. There's all kinds of different carburetors you can run with a blower. In fact, there's other types of systems you can run too, such as fuel injection. We'll show you that in a second here. Carburetors, though, you'll see a lot of dual 4-barrels on blowers. The reason is they're pushing a lot of air in. You got to meet that air with fuel. Sometimes it takes 2 carburetors to do that. Plus the cool factor, 2 4s, is pretty awesome. You know, 2 4-barrels on a naturally aspirated motor, especially a small displacement one, as we talk about in our performance carburetors video, you know, it can overpower the motor, lose all your velocity and stuff like that. We talk about you really need to have lots of velocity. Well, it doesn't happen with a supercharger because they're making the velocity. They're pulling the air through and pushing it into the motor. And you know, velocity makes flow. You know, flow makes power. So they're kind of taking care of that for us. But you'll see a lot of the 2 4s on there. On street motors, you know, just a small pair of 4-barrels like this, a small pair of 600s is fine. They can be vacuum secondaries. We run vacuum secondary carbs on a lot of street motors with no problems at all. Mounting them forward like this on a street motor is fine. If you have a really nasty motor, if we were building you something like a 750, 850 horsepower motor, that's going to be, you know, in a car that's got a back half system in it where you're tubbed out with some slicks or something, going to be launching off the line real hard, we'd probably not mounting the carburetor sideways on there. That way we don't get the bowl problems, the float and bowl problems of fuel overfueling and underfueling with fuel starvation because of the floats moving up and down in a particular way. When you turn a carburetor sideways, the floats aren't sensitive to forward and back motion. They're more sensitive to side motion, so forward and back doesn't affect it. But on normal street motors and mild street motors, you'll see them mounted forward like this, and there'll be smaller carbs like these 1850s right here. These are inexpensive Holley 600s. They work real well. I said before that blowers are real mild on the street. You know, when they're used in moderation with, you know, lower boost levels between 5 and 8 psi. Small carburetors are real reliable. The blower motors are reliable. I mean, everything's real good about the carburation system. As far as gas mileage, forget it. We're talking performance here. We don't look at gas mileage, so don't even think about that. But small carburetors give you good throttle response and everything. Of course, you can go to a bigger carburetor. On normally aspirated motors, when you go to a great big carburetor and you give it, you know, the throttle, especially double pumpers and stuff, you know, we call flushing the toilet because you open up all 4 barrels at once, and naturally aspirated motors can't take that. Supercharged motors, not a problem. We've got small block Chevys that run 750 double pumpers, sideways mounted 750s on these things that they'll get, man, you crack the throttle, they'll get up and go. It just depends on how much boost you're running, how well the motor's set up, and what it's doing. Everything has to be in moderation to be put together. That's kind of what I'm showing you here, of what to do and what not to do. We'll come over here. This is the fuel injection right here. There's different types of fuel injection. This one right here, believe it or not, is electronic fuel injection. This is kind of a state-of-the-art system that Blower Drive Service makes. This one right here, it looks like it's mechanical fuel injection, and there's a difference. Mechanical fuel injection runs off high fuel pressures, off a mechanical, what they call a positive displacement pump, which is a gear-driven pump, much like an oil pump is. There's a pair of gears inside there that force fuel, and you have to have bypass valves, idle bypass, high-speed bypass. You have a barrel valve. There's what they call a pill. That's what sends fuel back to the tank. All fuel injection systems have to return fuel to the tank. Mechanical fuel injection, though, you've probably heard some misconceptions that you can't run that on the street. They are temperamental, I have to say. If you don't know what you're doing with mechanical fuel injection, they are temperamental. You can run them on the street. When I was a kid, I had an injected small block in a Chevelle, and I'd be cruising the East Bay, Maine, up and down the Maine, driving around with a set of Hillborns on my car, and guys would come up and go, "Hey, that's injected. You can't run injection on the street." And I'd be like, "Well, I'm running here," you know. So you can run it. A few of my other crazy buddies that run cars in this business and stuff also run fuel injection on the street, mechanical fuel injection, and you can do it. But it is quirky, and they are temperamental. Well, to get rid of the temperamentalness of them and everything, we can go to mechanical fuel injection and convert it to electronic. So rather than all the mechanical pumps and stuff like that, it's much like a modern system where you have fuel rails. In fact, I can pull this off right here and show you. It's lined with Bosch fuel injectors. You have your fuel rails. It uses sensors, air density sensors, air speed sensors, air temperature sensors, map sensors, a computer, the whole schmear, just like your normal car has. If you saw a fuel-injected car, you would also find fuel rails, fuel injectors, and things like that. And very much like a modern car system. The cool thing with these is you get all the looks of the old mechanical blower fuel injection like this, which is great when the butterflies open and close. Got a nice little look right there, with the runability and tunability of electronic fuel injection. And we're on mechanical injection, there are no priming pumps or fuel pumps. There's no accelerator pumps. So you could do this all day and no fuel's going inside the motor. Not like a carburetor. Carburetors have accelerator pumps on them. So when you activate the throttle linkage, it squirts a little bit of fuel down the carburetor to help the engine start. Fuel injection systems don't do that, not mechanical or electronic. So what you'd have to do is sometimes you'll see at the races, the guys open up butterflies, they'll squirt some gasoline inside there, and then they'll ignite the motor. And once it ignites and kicks over, that spins the mechanical pumps fast enough to put the fuel pressure in to run the motor. Well, with electronic fuel injection, they're electric fuel pumps. So as soon as you turn the key to on, the system's pressurized. And that's kind of nice. So, you can do this all day. You're not pumping fuel in the motor, which is nice. Cool thing with electronic fuel injection, too, is you can just reach in, bump the key, the car fires up and sits there and idles, and everything's all self-tuning as it goes. Mechanical injection, they're temperamental to air density, to heat, to specific gravity, relative humidity, all kinds of things like that. And it might run real good one day on a hot day, and then the next day it's kind of cold and humid and cloudy. It won't run that good. You got to completely retune it. Electronic fuel injection, it does it all on itself. You have no troubles. You can be at altitude or at sea level and it'll run really good. Mechanical injection, not real good. But for all-out racing, drag racing or anything like that, they're all mechanical fuel injection. I mean, there's nothing that makes the power of mechanical fuel injection. Electronic is nice for the street. You get great throttle response, good drivability, and believe it or not, actually okay gas mileage. There's a lot of 5.0 Mustangs out there that run, not roots blowers, they run centrifugal blowers. But I've seen cars out there that get 17 to 19 miles to the gallon, and they're making 600 plus horsepower at the rear wheels. You're talking a 9-second street car that gets 17, 18 miles to the gallon. And these are the guys that daylight the front wheels about 4 feet in the air. They're insane, which is great. That's the beauty of a supercharger. But again, that's electronic fuel injected. Mechanical fuel injection on the track, nothing makes the power of that. But nothing is as good as the tunability of the electronic. So it's kind of nice to have best of both worlds on here, and you get all the great looks, and it's a great little system. All right, I said before that you can use vacuum secondary carburetors on blowers, and you certainly can. You know, the number one rule of thumb with superchargers is never lean the engine out, period. A lean motor, boy, I'll tell you, it gets hot, it gets too much oxygen inside there, and it will melt the inside of the motor down. You never lean a blower motor out, for sure. You know, so on a vacuum secondary carb, this one is a typical 3310 Holley. It's a 750 vacuum secondary, but it's been modified for a supercharger. And what we've done is, you might notice that some of you that are familiar with carburetors, it has a rear metering block, or what I call a jet plate, in the back. The carburetors, the way they come from the factory, this bowl right here is right up against the body, and there's a metering plate inside, which does not have rear jets. This one we've installed a kit, which you can purchase. If you have a 3310 carburetor, you can purchase one of these kits right here. And what that does, it comes with a rear metering block or a jet plate, which means you can put jets in it, and it's a kit to convert a 3310 over to have four jets in them. Reason you want something like that is for tunability, so you can change jets, because this, you know, the carburetors, all carburetors come from the factory designed to flow a certain amount of air and a certain amount of fuel. They don't think you're going to take a carburetor off the shelf, throw it on a blower, and suck all kinds of air through it and force all this air into a motor. You need to meet that with fuel, which means you're going to be doing a little bit of jetting, and you want to be able to have control over that. The rear metering plates, though, you really don't have control. You can buy different plates, but they're kind of a real pain in the butt. Where jets, you can have a whole assortment of them and go through and tune it to the correct air-fuel mixture that you need. So more about carburetors. Can you take a carburetor out of the box, just a typical everyday carburetor out of the box, and run it on a supercharger? Yeah. Do you have to have a carburetor built specifically for superchargers? No, we never did before. There are supercharger-ready carburetors now, though. When what they've done is, inside the carburetors there's power valves, and they take a reference of vacuum from underside of the carburetor. Well, the problem with that is, on top of a supercharger, come over here and look, they're getting vacuum into here, but inside of here is pressure. Okay, there's vacuum and pressure. The vacuum signals up here are a lot different than the vacuum and boost pressures down inside the manifold. So there are differences down there. So there are carburetors now that are available that have little ports on the side where the power valve is what they call boost referenced, okay? And what that means is it takes the vacuum signal down from the manifold, and what that does is it makes the power valve work at various times more correctly than it would without having that. But without that feature, I mean, if you just took a carburetor out of the box, can you do that and run it? Sure. We've been doing that for years, never had a problem. This just helps smooth things out, though. So if you're purchasing a carburetor and it says it has a boost referenced power valve, go ahead and get it. That's a better way to go. It's just a little more thought process put into it and a little more technology there for you to help the tunability and runnability of the car. But without it, they still run okay. Well, we've talked about different types of carburetors for superchargers. Let's talk about some of the little modifications you can do to these things. On blow-through systems, centrifugals with blow-throughs, the problem is the bonnet sits over the top of the carburetor right here. And right here, these guys are bowl vents. This lets air inside the bowls right here, just lets them breathe. Problem with a blow-through system is it forces air down inside here. It also pressurizes these bowls, puts a lot of pressure inside here. Okay, and that's okay, nothing wrong with that. Problem is, when you start running too much boost, it also starts blowing fuel out the throttle plates and things like that. So there are clamshells, which we'll see a little bit later, but there's clamshells you can put these carburetors in, and it pressurizes the whole thing. But the reason I'm telling you about this right now is I want to show you a problem you can run into. So when the bonnet sits on top and the discharge nozzle comes up and forces air down inside here, it pressurizes these guys, you got to be careful on what kind of floats you use. Most carburetors come with brass floats, and brass floats are fine. They're a hollow brass float, but they're thin and they're soldered together. And what happens is, when you start running up into some good boost, above 10 pounds of boost is where you're going to really start running into trouble. What will happen is, we have one right here. This was a brass float, and it's imploded. And you can see it's all crinkled right here. It used to be this shape all the way down, just right there, all the way across right here. And what's happened is pressure has imploded it. Just like a submarine going down too deep underwater, they implode, and that's what happens. So much pressure got in here, it actually squished this thing in, and what that does is it screws up the fuel delivery inside the floats here, and it changes its buoyancy, and they just don't work. I mean, if they wanted them to look like this, they'd make them like that, and they don't come that way from the factory for a reason. Remedy that, there's nitro fill floats. This is a nitro fill float right here. This looks a little different because this is for a side hung float. This other one was a center hung, but this is a side hung float. Still the same thing, still a Holley float, but they're made out of what they call nitrofill. It's a solid, almost like a foam, but they can't implode. They're solid all the way through. And when you go into supercharged motors with blow-through systems, you definitely want to go to a nitrofill float, or you're going to implode the floats and you're going to have fuel delivery problems and starvation. And like I said, you starve a blower motor, it's gone. It'll smoke it. So now you know that leaning a blown motor out, can really be bad on it. So the question is, can you use your stock fuel pump, your stock mechanical fuel pump? And the answer is, yeah, probably, if it's mild or a single carbureted one. But if you're running 2 4-barrels or a 671 blower or anything that's got any horsepower or anything to it, you got to keep the fuel delivery up. And here's an aftermarket fuel pump right here. I can look at this. A pretty good fuel pump. Problem is, look at the inlet and outlets on them. They're not very big. That's only 1/4-inch pipe, which means by the time you put the fitting inside there, the thickness of the fitting, the hole that's actually the orifice that the fuel is going to be delivering and the fuel that's going to be coming out of there under pressure isn't much more than about 3/16 or a 1/4-inch. Well, let's look over here at the carburetor. You look at this carburetor right here. We've got 3/8 inlets on both sides of these things, on either end. Well, how is a 1/4-inch hole supposed to supply 2 3/8 inlets on your typical carburetor? That's a lot of fuel that's going to have to pass through there. So there's some things you're going to have to do to modify your motor to make sure or ensure that you're going to get adequate fuel supply. One of the first things you're going to have to do is make sure that your fuel line going from the tank on up to the pump is big enough. You want at least 3/8. Most of aftermarket cars or race cars and stuff, we run 1/2-inch fuel lines or so from the tank on up. Got to have enough fuel to get there. Next thing is pressure and volume. So we can come over here to this fuel pump. This is what they call a 6-valve fuel pump. It's a really good, this is an Edelbrock one, really good pump. There's lots of other manufacturers that make good pumps. This one right here has 3/8 inlet over here and a 3/8 outlet, 3/8 pipe thread. That means the hole that's going to be coming out of there is about the size of your finger. By the time you take account the thickness of the fitting that's in there, you could run an easy number 8 line coming out of here, what they call a -8 or a number 8, or a number 6. And number 6 is about as minimum as you want to go. I'd prefer to see a number 8 line. There's something you might notice about this pump that's a little different than the pump you have. Has a fitting put in it right here. This is what we call boost check. And if you're going to run a mechanical pump with your supercharger, it's a good idea to run boost check. And what is that? Well, underneath the blower, when the blower's compressing air, the manifold becomes under pressure. Okay, well, we take a tap line out of there, a number 4 line or just a 1/8-inch like an oil pressure style line, right on down to this right here. This right here is a -4 fitting. We pressurize this. Well, what's inside here are diaphragms that push up and down to make the pressure. Okay, well, when the blower goes into boost mode, it puts boost right inside the fuel pump here. And what that creates is every pound of boost more that you get 1 more pound of fuel pressure. So this pump right here is set at about 7 psi, which that's about what you want to run, around 7 psi at all times. You don't want to, and that's even at wide open throttle. If you have a fuel pressure gauge and you're at wide open throttle and your fuel pressure starts dropping down to 3 or 4, your fuel pump ain't adequate. You need more, or your fuel delivery is not adequate. You need to keep that up. Well, what this does right here is when you're under boost mode, it puts air pressure down inside here, pushes on that diaphragm harder, which makes the pump grunt more and put out more fuel pressure. So as the boost comes up, the fuel pressure comes up and stays with it. And these things usually go up to about 16 or 18 pounds of fuel pressure, sometimes 20 pounds of fuel pressure as you put boost in them. And that keeps the pressure and volume. Remember, pressure makes volume, okay? So it's making the volume to supply the carburetors with the fuel. And you can do that with a mechanical pump. Of course, I'd rather see you run an electric pump, a good electric pump. And the reason being with that is when you have 2 carburetors, especially 2 4-barrels, the float bowls on here, the capacity of them is quite a bit. I mean, there's at least a 1/2 cup, 3/4 of a cup of fuel in each one. Times that by 2 carburetors, now you got four bowls and everything, float bowls. That's a lot of fuel. Well, let's say you need to do an adjustment and you adjust the carburetors, you want to do a bowl adjustment. That's what these little guys are right here. You take these sight plugs out and you can adjust the fuel level. Well, the only way to do that with a mechanical pump is to start the car and run it. And it has to be running in the engine because the camshaft drives the eccentric on here, or the eccentric on the cam drives the fuel pump. Problem with that is, what if your car doesn't run? You got a supercharger, it's brand new, you got a new motor, and you want to adjust everything, and you got problems, and you don't know where your float levels are, anything like that. Well, you got to get it to start to be able to do that. Electric fuel pumps, you just turn a switch on, it pressurizes everything. These things fill up with fuel. You can adjust them. You can work the throttle linkages, make sure all the squirters and accelerator pumps are working. That's a better way to go. And electric pumps tend to flow, well, not tend, they do flow a lot more fuel than just a mechanical pump. You're not going to see a mechanical pump on a hardcore race car. They always have electric pumps. And they run fuel pressure regulators and stuff like that, which you're definitely going to want to run. So on a mild motor, something such as one of these right here, 450 to 500 horsepower, you know, a mechanical pump like this with a boost check on it, that's fine. With two small 600s, you're not going to have a problem. Anything beyond that, you're really going to have to upgrade. If you start getting into some serious horsepower, you're going to have to get up on that. Let's talk about a little problem that you can have with carburetors with blow-through systems with centrifugal superchargers that run air bonnets on top. Anytime you do that with an automatic transmission or accessories that are driven by vacuum, you can run into troubles, because what happens is air pressure going through here, all the vacuum ports become pressurized. And like your automatic transmission, they'll take a vacuum signal right down on here. Right down in here, there's a vacuum port on here on most carburetors that run your modulator valve on the automatic transmission. Problem is, modulator valve needs vacuum to upshift. When you're on centrifugal superchargers, they build pressure up, so sometimes you won't have vacuum and the transmission doesn't know what to do because the modulator's not getting a vacuum signal. Another thing you can run into are PCV ports, power brake ports, and things like that. On blow-throughs, these all become pressurized because pressure is going down inside the carburetor. Occasionally, in some situations, these will all become pressurized. So power brakes, you can actually apply pressure to the power brakes rather than drawing air out. If the check valve's not working, it'll push air back in or blow the check valve out that's in your power brake booster. So there's things you want to take into consideration about bolting on a supercharger. Make sure you read their the manufacturer's instructions really well, because they have little check valves and check balls and stuff like that to prevent pressure from going to places that it shouldn't be going. So don't just get one you know, at a swap meet or anything like that used and think you're just going to bolt it on. Chances are you'd be just fine, but there are tuning little things like that that you want to be careful of. And there's one other thing too, I just mentioned that if you go to a swap meet and buy something, never buy a supercharger at a swap meet. If someone's got like a centrifugal supercharger new in the box or maybe slightly used, that's okay. Or if it's a roots blower that looks brand new, that's okay. But do not, and I repeat myself, I'm adamant about this, do not buy a used supercharger. You'll see them sitting there for $300 or $400. Oh, it came off a farm tractor, or it came off my GMC diesel. It's going to cost you so much to get that one supercharger rebuilt than it would to go buy a brand new kit with everything all in it that's polished and brand new and ready to go. One of these basic kits, they run about $2,500. And you think, oh man, that's a lot of money. Well, I'll tell you what, when you buy a bare supercharger and it's missing things like pulleys, these pulleys are expensive. They're $100 a pop, okay? The belts are expensive, the idlers, I mean, all the stuff. The intake manifold's expensive. The carburetor adapter plate's expensive. These things aren't $2,500 for a reason. You go to and that's a cheap one. You get into a hardcore race one, they're $4,500 or so, okay, just for the supercharger. I'm not talking about the, you know, the fuel injection. This fuel injection system right here is $6,000. Okay, so you're talking big money. So we're not even getting into that. I'm talking about the blower. And I see time and time again, guys come into the shop, hey Aaron, I bought this blower at a swap meet. I only got it for $300. I need to buy some parts for it. And we start adding up what it's going to cost to get that blower re-clearanced inside or re-Tefloned, get the gear plates, the drive plates rebuilt, get all the pulleys for it, get the manifold for it, get all the studs and all the hardware for it. You're going to have more into it than if you just bought a kit, buying all that stuff separately, and then what you got is some rebuilt old supercharger. Buy a brand new one. Don't buy a used one, because it's nothing but a bunch of headaches. And to this day, I don't think I've ever seen anybody buy a used one at a swap meet and successfully put it on their car and run it, unless it was bought as a complete kit where someone put it on their car, ran it for a little while, and took the entire kit off and sold it. That's a little different story, but I'm talking about an old farm supercharger, something off an old hay baler or something that's got a big diesel motor in it. Do not buy into that stuff. They're just junk. All right, we've talked about on roots blowers, boost and atmospheric pressure and the ability of a blower to add cubic inches to a motor. We talked about 14.7 psi as being our natural atmospheric pressure. Well, when you add 14.7 pounds of boost, like I said earlier, to any particular motor, it'll double the cubic inch size of that engine. Well, the same thing with centrifugals, okay? They do exactly the same thing. This 500 cubic incher right here, at 14.7 pounds of boost, okay, this 500 cubic inches becomes 1,000 cubic inches, all right? Figure 1 horsepower per cubic inch, that's 1,000 horsepower. All right, so of course that's not exact, that's mathematics. I mean, it takes a real dyno to do that. You can't do it just in mathematics. There's too many factors involved with camshaft profiles, compression ratios, fuel octanes, I mean, all kinds of things like that. What they call volumetric efficiency of the motor, I mean, all kinds of things like that that have factors in that. But the reason I'm talking about capacities right now is because on blow-through systems, they increase the CFM rating of a carburetor. This is an 850 on here. Okay, so it flows 850 CFM at normal atmospheric pressure, okay? Well, when you put blow-through boost through the thing, it'll increase it, okay? So this 850 becomes 1700 CFM by adding 14.7 pounds of boost to it. Or for instance, if we had a 600 CFM carburetor, like a typical Holley 600, and we add almost 15 pounds of boost to it, that becomes a 1200 CFM carburetor. That's kind of in theoretical too, that's mathematical, but that's a general rule of thumb. Of course, I'm talking about 14.7 PSI because the math is easy. Of course, if we did half of that, you're talking about, about 7.5 pounds of boost. That gives half again as much to an engine. So if this was 500 cubic inches, it would add another half of 500. So it would be 250 cubic inches. So this 500 cubic incher at 7.5 pounds of boost would become about 750 cubic inches. Well, that's about 750 horsepower. In reality, on a dyno, probably more like 7, 7.25, something like that, but right in there, and gives you a good general rule of thumb. But I just wanted you to understand about capacities, and anytime you add pressure to something, pressure makes flow. Well, these are rated at a certain flow. Pressure increases that, it's going to increase the flow capacities of a carburetor, and pushing flow into a motor and pressurizing a motor also increases its cubic inch displacement.